We are going to get started. So what I'm doing today is I'm trying to create like a solar powered uh, YouTube subscriber count, just kind of goofing off with like this little idea that I had. And so, um, yeah, I guess we'll get started. Yeah. Um, I just have to switch over. Okay, so the different pieces that I have. This is an e-ink screen that I'm going to use. I felt like this was probably the best option in terms of like low power. One of the super cool things about e-ink is that even after it's off, it holds whatever it was told to, or it displays whatever it was told to display. So like that's not printed on the plastic. That's the screen is still displaying that. And this one works. I think it's a SPI interface. So this little connector here gets plugged in. There, we'll solder that in, and then we use. Oh no, huh. I guess you can do that. But why would you do that? Because you have this cable right here. You plug this in there, and then you have these fittings here, and Bob's your uncle, I guess. So that's one piece. This is I think they call it a TP4056. It's a LiPo battery charger, so it's going to charge this battery. And so I'll plug the solar panel in here, and then the solar panel will use this to charge this battery, and then we will power the ESP32 off of this battery. And then I have a couple of resistors so that we can create a battery voltage display as well. And so these are perf boards. So I'm thinking about using something like this to solder it all together. But I don't really know exactly how that will work. I wonder if there's any smaller ones than that. I don't feel like I need anything super big, but everything I have, I think this is the smallest one that I have. And yeah, so I don't know how I feel about all of that, if that's the right way to go or not, or if it's just better to build it out as individual pieces and then 3D print something. Actually, I think that's what I'll do. I'll build it out as individual pieces. I won't use the perf boards. And then I'll go from there. So step one is kind of the scary part because I don't have a connector for this battery. So I'm gonna have to cut these wires off, and if you were to cut across them, you could short them and start a fire, and I don't want to do that. So I'm gonna do them one at a time and build out a new connector for that. What I may do is I may just cut them and then solder them directly to this, and that kind of saves me like using some connectors and stuff like that. So I think that's the route I'm actually gonna go with this project. Just keep things kind of simple and easy. So we'll start by cutting the red wire, making sure we're just cutting the red wire, and then we'll cut the black wire. There we go. Okay, and now that's done. So now I'm gonna try and do these one at a time. So what I'll do right now is I'm gonna strip a little bit of insulation off this red wire. And then I'm going to take some electrical tape and just make sure that that doesn't remain exposed so that the black and the red couldn't touch each other accidentally before I get everything soldered up. There we go. And then we're going to strip the black wire a little bit. One of these days, I'm going to buy real wire strippers. Okay, so that'll take care of that portion. Let's see. Turn this way. All right, so I'm going to take the negative. Now I'm going to do the positive. I wonder if it's triggering to anybody that I'm soldering these through the underside. If it is, I'm sorry. Not my intent. I didn't think it'd make a difference, and honestly, I thought it would make for better footage. All right. See that okay? Okay. So just double checking. The red wire goes to B plus. The back wire goes to B minus. So theoretically, I should be able to test this and plug it in, and it'd work. So here we go. Let's just check the voltage on this and see what the voltage is reading. Just because I'm curious. We've got 4.7 volts right now, or 4.07 volts, sorry, 4.07. 4.08. So it is charging. Slowly, but it is charging. So that's awesome. Okay. So the next step in our process is to solder on here and connect this power to the ESP32. So I'm going to get a couple wires cut for that, so we have a little bit to play with. And the ESP32, the 5-volt power is up here, so I'm going to solder this right into here. That's ESP all soldered together. It's good. This is the portion where I'm actually a little bit nervous, though. Soldering this to the actual charging board, because this means the ESP32 is going to be powered 100% of the time now, because I made the executive decision to not install a connector for the battery, which I'm beginning to think was not the wisest course of action. But we did it. So we're going to keep moving. And hopefully we don't do anything stupid. I don't know if you noticed, but the red light on the ESP32 is now on because it's live, it's hot, it's being powered. Don't do this. Don't make the same mistake I made in like soldering this up now. I should have, looking back now, I definitely should have added the connector. I didn't think it through. I was moving too quickly. You ever do that with a project? Anyway, it is what it is now. ESP32 is powered. Now I want to create a battery monitoring circuit so that I can be able to write to the e-ink screen how much charge is on the battery. And to do that, I need a voltage divider. And I think at this point, I am going to use that small perk board. I have it, and I think it'll just make everything so much safer in terms of the whole connection and everything. It will mean the base has to be a little bit bigger, but I think it's just smarter. I already made one bad decision. Let's not make another. So what you do here with this voltage divider is I need a 1,000 ohm resistor and a 10K resistor. All right, so this is my 10K resistor. And I'm gonna All right, so this is my 10K resistor. And I'm going to solder this one on this side. So that's my 10K resistor. Now I need 100K, I think is what it said. Just looking through all these resistors. Oh, here's the 100K. Sweet. Take this out. Now, before I put that one in, because I know that it's been a long time since I've tried to read these stripes on a resistor to understand what their resistance is. So before I do that, the 10K resistor, one end goes to ground, and one end goes to one end of this. So what I'm going to do is I'm going to go ahead and cut a ground wire so I can make that part of the circuit. And then I'm going to put this 100K resistor in. Now this is something I haven't done before. Trying to create a solder trail, create a solder trace on one of these perf boards. Let's see if I can do this. All right. Not too bad. Not too bad. All right, and then the other side of this 100K resistor gets this red wire soldered to it. Okay. Okay, and then it says I want to connect this to the voltage out here. So I'm going to cut these extra wires off because I don't want them getting in the way now. All right, and then this gets connected to here, but it tells me to do this one first. So I'm going to do this one first. This one has to go to the negative. Okay, the more I'm playing with this, the more I'm realizing the more I'm playing with this, the more I'm realizing what a bad idea it was for me to not have some way to cut the power to this. I don't know if I'm in too deep already not to be able to do that. That's definitely something I'm giving a lot of thought to right now because I just don't feel like this is a smart way to do it. But I'm also like actually pretty close to being done. So it's like, what do I want to do? And the other thing too is like, where do I break the circuit, right? Do I make it so I can disconnect the ESP32? That doesn't make any sense, right? Disconnecting the battery. And I'm kind of like, I don't really want to play around with the battery a ton because of like, the danger of the battery. Uh, I got an idea. Since I decided to go ahead and grab this perf board anyway, what if I just so now I have this. And what if I remove the battery here, add this type of connector onto it, and then I solder wires from here to there? I think this is what I'm going to do. And I'm going to start with the positive and try and not do anything stupid. Sorry, I'm totally cutting you out of the shot. Give me a second. There we go. Positive is out. I need to be very careful about what I let touch at this point. Oh, gosh. Come on now. All right. Well, I cut a little bit of that off. Now what I'm going to do is I'm going to take this connector and I'm just going to plug it in there. And now I feel relatively safe because theoretically stuff shouldn't easily touch at this point. So let's do the same thing to the black. Right, if I did all this right, should be able to plug this in here. That. Now I could plug this in here. That. And now if I check voltage here, I should have somewhere around, what were we saying? It was reading 4 volts. So let's just see, is it reading 4 volts? It's not. All right. So let's just see, I'm going to stick my positive here, my negative here. And I have 3.89 volts. Okay, so this connector is working. I probably just didn't get plugged in all the way. So let's go ahead and try again. Get that plugged in good. And then let's go ahead and hold this steady so I don't have to hold everything, and just see, am I getting a good decent voltage reading? I'm not. It's definitely plugged in all the way. Why am I not getting voltage reading here? But I definitely get voltage here again, right? Oh yeah. Okay, so it's not a crimp issue. Oh, there we go. Now I'm getting voltage. Okay. Maybe it's just a plug-in issue. I'm not sure. But I feel a lot safer with this setup. I feel like this is the smarter route to go. And so now what I can do is I can solder from these two onto here. So I just need 2 more wires. And what I'm going to do now is unplug the battery, because it's the battery. I thought that was obvious. All right, so when I plug this in, the red is here, so I need to make sure to solder that to the right one. Okay, seems pretty secure. There's a big potential for wire crossing, so I'm going to go ahead and plug this in and just see, am I getting what I expect here? Yep, voltage, and it's the correct polarity. Let me just double check that, checking polarity. Yes, it's the correct polarity. Excellent. Okay, so that's good. So now I can disconnect the battery. So I'm safe again. And then I can solder the negative to the negative. Okay. Wait, with this setup, theoretically, I should be able to plug in a USB cable and see this turn on. I'm going to do this first because this is less likely to cause a bad fire than the battery. Excellent. Everything turned on. Now, I should be able to unplug this, plug in the battery, and this came on. Now if I plug this in, okay, and let's just check voltage and see what we're getting. Okay, looks like it's charging. So that's good. So I can pull this, turn that off. Now for the circuit to work, for my checking of the circuit, I'm going to solder from 0 to this middle section here. And I'm going to use a green wire as like a signal wire for this. Okay. And this will go right here between these two resistors. All right. Wait, now, what do I have left? I need to solder up on this. I need pins 6, 4, 7, 2, 3. 6, 4, 7, 2, 3 are the ones that I need. I wonder if I should have installed the headers instead of just soldering wires directly to this. Let's see. I need 1, 2, 3, 4, 5, 6, 7. Okay. I think I'm going to try something. Probably should have done this in the beginning. You know, I think I too quickly dismissed the perf board. I was like, no, we don't need it. We don't need it. I think that was a mistake. I think we do need it. I think we should have used it right from the get-go. Some of you were probably saying that. All right. It's always a pain to get the solder out of those little... Okay, and then... Here's the headers. Oh, man, you know what? I think this perf board is too small. No. All right, well, I'm just going to solder on the headers then. Yeah, I think this perf board is too small in both directions to use this ESP32. Yeah. It's one row too small. Oh, what a knucklehead I am. All right, no worries. We can solve this problem. All right, now I just got to solder all these pins on. Should have done this from the get-go. Well, you know what I really should do is like have this held for me so I'm not holding it. Hey, that's better. The downside is I have this perf board that I'm not actually able to use, although I can use portions of it, I think, because I could slide this through here, solder it, and then solder the power to it. With that, because I need like 4, or I need like 3. Nah, I don't like that. I think what I'm going to do is I'm just going to solder the power, the data, and the other lines directly to the top of this. So I still have power soldered on, and then I'll use those wires as data wires. I think that'll just be the easiest way. Just want to make sure that I don't have any of these have that ground wire cross soldered with the other pin. All right, let's see if this works. I think it will. It doesn't. Are we getting voltage here? Did I just fry this board soldering on it too much? Let's see, does this have to be plugged in? I feel like there's something wrong. Let's do this. I'm not getting anything here. Yeah. I think I either have something crossed or I just overheated this ESP32. So I'm going to switch to a different one. I got a couple of them. Let's just check and see if that solves our problem. Yeah, okay, so that had the red light and the blue light, and then when I plug this in, it goes red that it's charging. Unplug it, it goes blue. Okay. Yeah. All right, so it's just the ESP32. I think I just overheated it. Let's grab another one. All right. And I'm gonna have the basics started. Let's get the rest soldered in. All right. Now let's Solder the power to the 5-volt. You know what? Actually, I'm going to go a different route. I have bottom connectors. And I think I should just use these. I'll need 3 of them, right? These things can be like, have you ever used these? These things, these right here, have you ever used these? Yeah. They can be a little bit of a pain to get, like, on. I find like the easiest way to get them working is to have them at is to have the wire crimped like fairly short. That to me reduces the biggest chance of success. Okay, this one ain't gonna work. You also have to make sure that you leave enough room so that the wire can get. You almost want to like set them in here first, and then in here. I personally haven't had a lot of success doing it this way. Hey, that looks all right. I'm gonna switch to continuity and then just check the continuity. Okay. I always like to do that just to make sure it's all connected and working. And then for this, I'm going to do the singles. Like this. Okay, and then I should be able to, like that. Okay, good, good. All right, so I got 2 more that I got to do. Set the wire in. Set this on top. No. I got it up. Saved it. Okay. Trying to twist the wires together so they don't fray. And then this has got to go in here like this. And then in here like. Oh, this one's already busted. It's crimped too much. I can't get the wire out. Okay, gotta do another one. I find that I only get about 50% of these. Don't have a high success rate. Okay, check the continuity here. Good. Let's do this. And then that allows me to plug in the negative for the ground, right? So then theoretically now, make sure these are working. If I plug this in, should power this guy on, which it does. Wait, what happened? Oh, ground came out. Oh, look at that. Okay. Is that better? Seems like it. I don't know that I necessarily need to test it again, but I'm going to. Cool. Looks good. Everything's working. Okay, so now I just got to do the green wire, and that's going to go on 0. And then I should be able to wire up the screen. And then we get to the hard part. Okay. I think that takes care of all the wiring. I'm going to clean up for a second, and then we need to start. Okay, it doesn't take care of all the wiring. I need to connect all the stuff that we've just done. And then Or down. All right. So I think we have everything. We just need to plug this in now. This is the last bit of wiring we have to do. Plug this in. And then wire it up. Which should be fairly easy, I think. Famous last words. Okay. And then how do you wire this up? Let's see. So it says that this wire is VCC, and VCC is going to go to the 3 volt here. And then black is ground, and so that would go to ground. Only the problem is I'm using this, so I can't connect this. Great. Okay, we'll come back to that. Next is yellow, which is SDA, and SDA goes to what? SDA. I don't know. Let's come back to that. SCL. I have SDA, SCL, CS, DC, RES, and busy. Okay, so SCA is the yellow wire, and that's supposed to go to 6. Which is here. And then SCL is green. And green goes to 4, which is right below the 3.3 volts. So here. And then we have CS. Wait. Yeah, CS is blue. And that goes to 7. Which is, yep, is here. All right, then we have, just in blue, we have white, orange, and purple. So it's DC res. White is DC, and DC goes to pin 2, and pin 2 is right here. And then we have orange, and orange is res, which is reset, and that's going to go to 3, which is here. And then we have wait, what did I do? That's wrong. Purple is busy. Orange is reset. And then reset goes to pin 3. Should I just do that? No. I just plugged reset into, wait. Okay, hang on. Yellow is SDA, and SDA goes to 6. Yellow is going to 6, correct. Next is green. Green is SCL. SCL is going to pin 4. No, that's the problem. SCL is going to pin 3, so I need to flip these two. They are backwards. So green goes to 4. And that goes there. And then busy goes to 5. Busy is purple. And purple goes to 5, which is right over here. Okay, so now I just need to figure out how to connect this ground. And I have an idea that I think should work. Mostly effectively. Without like being too crazy. What I'm going to do is I'm going to do one more. Let's see, what do I want to do? I want to do that's not going to work. I think I said I get half of these, and based on this stream, that is not true. I do not think I got that. Let's just see. Do I have continuity here? I do, good, okay. And what I'm going to do is I'm just going to solder this to the ground that we are using. I think I'm going to do it to this one. And then, so I think that means that this green wire goes into 0 here, and then this wire goes into here. And that should wire everything up. So now I'm ready to go on to the programming actually. And so I want to just clean up a minute, get this stuff put away, and then we're going to get into figuring out how to program this, which I've never done one of these before, so this should be exciting. Okay, so let's see. I'm going to switch over. So I'm going to go to Platform IO. Say create a project. New project. The project name I'm going to give it is, I'm going to call it sub counter, or let's call it YT. And then the board we want, we want the resif C3 dev kit M1. Let's let this build this up. Okay. What I'm going to do is I'm going to, I need to move some windows around. Sorry, give me 1 second. Okay. All right, and okay. So now go ahead and feed our prompt in and see if it will write the code for us. Now I just realized I'm not sure if I have a USB cable that can transmit or transfer data. Let me see if this we can. Otherwise, I'm going to have to go grab one. You try and have everything all in one place, and it doesn't always work out like that. Nope. That one doesn't seem to work. What do I have around here? Do I have one in here? No, no. Oh, there's one. I'm just cleaning up here. Give me 1 second. All right, what did it say? Says I completed the sketch, implements Wi-Fi, YouTube, e-paper, rendering. Okay. Let's see what a quick compile does. We'll allow it to run. It may be looking for something it's not going to find. I need to plug in the data cable so that works. All right, let's try just to build ourselves. Oh, it's loading a library right now. Just going to see if it builds. So it needs a Wi-Fi ID, a Wi-Fi password, a YouTube API key, and a YouTube channel ID. Pretty basic stuff, but stuff that I don't want to like set up on the stream right now because I don't want to dox myself. But let's at least see if the screen is working, and then I'll see if I can grab that information, plug it all in, and we'll see what happens. But I'm super interested to see if the screen actually works. Okay, it built. Let's upload monitor, and let me. So this is what the e-ink display currently shows. See if it updates with anything interesting. Let me. Okay. Nothing on the monitor, and it's not really doing anything. So let's do this. Okay, we're gonna just see what else. See if we can just like get like a default like, hey, can you just on boot let us know what's going on, you know? Oh, and let me see if I can steer it and say, also, could you include a battery percentage on the display? I love this new steering feature that AI has where while it's working, you can kind of give it a little more direction. It's really nice. Like that's a, oh, nice. Okay. Excellent. 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 Yeah, let's keep that. And let's flash it and see what happens. Let me flip you over to the e-ink screen. Okay, we got a little bug here. Let me just copy this and paste it in. See if we can get that fixed. Looks like that was the only bug. So if we get any more compile errors. Nope. Looks like that did it. Oh. Now we got an upload error. Let me just unplug, plug back in. Try again. Test. Okay. Okay, it's uploaded now. The screen is definitely not rendering anything. Makes me wonder if I have something connected incorrectly or what. Let's just see if the screen has power. So to do that, I can see here that 8 is voltage and 7 is ground. So I'm just going to see. I go I got 3.3 volts. Okay, so I've confirmed the screen's getting power. That's good. Let's just see. Let me just do an upload. Nothing else. We're just going to upload. Hmm. One thing that's interesting is this ESP32 is not being detected by my computer anymore. Let me see if I can. I forget which one of these is boot and which one is reset. Let me see if I can hold the boot one. Okay, it's this one here. Let me hold this one while I plug it in. There we go. Now it's picked up. Okay, so that's all it was. Let me try and flash it again. We're going to upload it. I'll just see if that changes. It does not. I wonder if I have something wired incorrectly. Let's just ask ChatGPT to look through the code and see what it might be. Okay, so it's giving me a minimal test sketch. What I'm going to do then is I'm going to go into the, oh, I bet that was the problem before. Okay, I'm going to stop this, boom. Let's initialize a Git repo, add everything. Probably should have a git ignore, but this is a simple project and I'm trying to move fast. So I'm not going to do that. All right. So now what I'm going to do, since I have all that committed to the repo, I'm going to go ahead and just copy this message here, select all, paste. We're going to paste in the minimal. We're going to save this, and then let's upload this. I think it did want me to upload monitor, but let's just upload this and see what happens. It does say it was a success. Not seeing anything on the screen. Let me unplug, plug back in. Still don't see anything. Let me do an upload monitor. Okay, so this is interesting. Let me show you what I'm seeing. So this says open a serial monitor, which upload monitor should have done that. I don't know what the baud rate. Oh, I think the baud rate is a little low. I think you changed that here. Um, think you changed that in here. It's been a minute since I've done that, but let's just see if it tells me. You could set it in here. Yeah, that's what I thought. It's one of the things with AI is it will give you an answer, but it may not give you the best answer right off the bat. So let's go ahead and do it again. Upload monitor, see what happens. And according to this, what was it saying? It was saying we should see clean or cleared screen and the road test page. If logs show but the day's flat, change suspect wiring driver mismatch or panel power charge pump. If the logs do not show, the MCU may be resetting or going immediately to sleep. Check reset GPIO 0 wiring to avoid accidental boot. Oh, that's interesting. I think it's going to be a wiring issue because I thought GPIO 0 was our voltage monitor. Okay, we've got the baud rate. Looks good. No messages. Okay, I do not see the messages. Cleared screen or wrote test page in the monitor. Currently GPIO 0 is, what is GPIO 0? GPIO 0 is my voltage monitor pin. Is that right? That's what I'm calling it. I don't know if that's what it would call it. That's what I'm calling it. We'll see. Okay, so it says immediately remove your voltage divider from GPIO 0. Okay, done. And then open the serial monitor. All right, let's do that. Okay. I disconnected GPIO 0, but I still see no messages in the logs. Check the main.cpp. You understand the code we are running. See what it says. Okay, so it wants me to hit the board reset button. Done. Okay. Hitting board reset button does nothing. I have you know what board I'm using, and that you can verify the platform IO board in the INI file. Can you check and make sure it's right? Okay, disconnect the e-paper, any external wiring, battery divider, busy reset. So only USB and MCU remain. Then reset and watch the show. If you get prints, if you get prints, peripheral was blocking. Okay, so let's try that, right? So I'm still quote unquote serial monitoring, so I'm actually going to unplug it because I don't want to mess around with and destroy the e-ink screen. I'm going to go ahead and unplug it. Then I'm going to plug it back in. And then I'm going to kill the current monitor. And let's upload monitor again and see if it prints anything out with the e-ink screen disconnected. Disconnected the E. Yes, sorry. It's my voltmeter paper screen. And from the board, but left the wires attached to the ESP32, and I still get no serial messages. Let me take a look at this. Let's just look and see serial begin, delay, print. So, I mean, you're supposed to get that like instantaneous. It should print immediately, which is kind of interesting that it's not. Because if I remember right, this setup runs and then the loop runs. So this is like the first thing it should do. All right, so what does it want me to do? So the I9 looks correct. Let's just try resetting the board. I'm not seeing any serial output. Okay, it's wanting me to check device manager. And when you look at the ports in device manager, there is COM8. And if I unplug this, COM8 goes away. If I plug it back in, COM8 comes back. So it's looking good there. So let's see. If If I unplug the board, COM8 disappears, and plugging back in, it reappears. Okay, it says press boot while pressing reset. So let's press reset and boot. Nothing seems to happen. Let's patch main to a minimal debug sketch. Let's keep it. What do we have? I like this. I like this. Let's run this. See what it does. Man, am I just missing it? Let me grab a different board. Oh. You know what's interesting? The LED is blinking right now. Let me show you that. So this LED high-low that it's doing is working. I'm not getting any serial output. Currently, the LED is blinking blue, but I'm not getting any messages. The terminal serial output. All right, what does it say? Let's run this in the terminal. Okay. I was wondering about that. Let me see, is it available in PowerShell? No. Oh. I don't know if I have Python installed. Let's get Python installed. See what happens. All right. Let's open a new terminal. Nice. Okay, so we're going to do install platform IO. All right, and then let's see, does this work? Of course not, because I got to open the terminal again. Nope. It must not be adding it to the path. It wants me to go here. Let's see, project. This is project tasks. Where's project tasks? Oh, here's project tasks right here. And then go monitor. Still COM8. All right. We're going to go a different route. Bear with me 1 second. At this point, I'm kind of frustrated, so I'm like a little bit going more insane on it. And let's do this. This is the original project as it was written. See what it says. Using Opus for this feels a little overkill. I feel like GitHub should have been able to figure it out. I know I was using 5.3 mini, but still, I kind of figured that would be enough. But we're not making any progress, and I want to make some progress. I only have like 20 minutes left. Welcome to all those watching the stream. Hope you're having a good Sunday. If this gets working, I'll have a better Sunday, that's for sure. So just kind of summing up where we are right now, trying to get an e-ink screen to work off of a solar panel so that I can show a live subscriber count. Just kind of a goofy little project because I wanted to try and get an e-ink screen working, wanted to play around with it. And I had this solar panel, tiny little solar panel that comes off of a like an outdoor video camera that somebody gave me because the camera broke and they were going to toss it, and I asked if I could have it, and they gave it to me. So I thought that would be a fun project to work on, and I thought an e-ink screen would be good because it would be good for power management. So that was kind of everything that was in my mind in how this project would work. And at this point, I feel like we've got everything wired up, everything soldered up, and everything should be working, or I feel like it should, but we're just working on the code now, and we're just not getting any real data from the e-ink screen. The ink screen doesn't seem to be doing anything, so I don't know if it's the code. I think it's the code. I don't think it's the ink screen. I really think it's the code, but that's kind of where we are. So I couldn't get the code working, so I initially decided to just go ahead and switch over to Claude and see if it could get everything working. So it says, how are you connecting to the ESP32 USB-C? Yeah. What battery you're planning to use? Yes, a single cell LiPo. Is the strap boot strip pin on the C3, which is why the divider can interfere with that boot. Are you okay moving the battery to GPIO1? Is GPIO1 being used? I don't think it is. No, it is not. So yes, I'm fine. Yes, GPIO1, that's perfect. We're going to say yes. And so it's going to keep on going. I'm going to unplug this, and I'm going to go ahead and, while I wait for this to do something, I'm going to go ahead and switch this over to GPIO. I'm going to switch this over and plug. So this green wire was my voltage divider wire, and so Claude just said plug it into GPIO1, so I'm going to do that. And then I'm going to go ahead and plug the screen back in. We had removed it for testing, but I'm going to go ahead and plug it back in because I don't know. Again, I think the problem is with the code. I'm hoping Opus can solve that for me. I won't have to dig into it. That's my hope anyway. We'll see how that goes. Okay. And it's still processing, trying to figure stuff out. We'll see what happens, but it's taking a minute for sure. Okay, so it built out a plan. let's take a look at this plan and see if it makes sense. I typically have AI build out a plan for me first. So it says it's got the board, native USB, yes, yes. Nothing appears in the platform serial monitor, yes. Screen never displays, yes. Voltage divider is on 0, was disconnected. So it has 2 distinct paths. You are 0 on pins 20 and 21 for the Arduino serial. Okay. All right, so these are the proposed changes. It's going to fix the serial over native USB. Okay. A lot of this I don't understand, so I'm going to accept it. Let it make those changes, and we'll see what happens. Maybe it works. I kind of hope it works. I have to say that having the ability to like use AI to assist me with various projects definitely makes things much, much easier. For sure. So right now it looks like it's just rewriting the main CPP. And when it does finish, hopefully everything works. That would be awesome, but it's gotta be close. Gotta be close. And yeah, if it works, this would be really cool. But now it's just waiting. Waiting, waiting, and more waiting. Come on. It's funny, as fast as AI is, it's still sometimes not fast enough for us. I don't know why that is. Maybe it's because I'm completely impatient. That could be the reason. That's definitely a possibility. Definitely a possibility. I just feel like I'm so close. Oh, it's going to build the firmware. I'm just going to build it myself. Oh, I should have done upload monitor. See, if this works, one of the things that's interesting is it had to set the USB mode. And if that is potentially what the problem is, it's funny, like sometimes you get like these AI models that just skip over something that could be just really, really basic. Let me go ahead and do an upload and monitor because I just did upload. I didn't do upload monitor. But everything is connected like it was before. And we'll see then if the screen updates. And It's just flashing it right now. Oh, look at that. Okay, so this is cool. We're getting serial monitoring information. Let me show you though what I'm seeing, because I think this is good to know. The e-ink screen still has not updated. There's no change to it whatsoever, but we are now getting serial monitor information. So that is good news. So I'm going to go back over and just let Claude know I'm seeing this information in the serial monitor. And the voltage divider, which should give us our battery percentage, is connected to GPIO1. Okay. So at least we're getting stuff in the serial monitor. That's good news. That gives us some definite insight into kind of what's going on, but it's not as good as if it was like actually working. So at this point, what I think must be the problem is it must be that I have something wired incorrectly. I did check the voltage earlier on the e-ink screen and it was working. But I think at this point it's got to be a wiring issue. I think I just need to rewire everything and double check everything. Oh, okay. So panel no is it trying to detect the panel. So it's not detecting the panel. That's cool. And so it says, I assume busy would go high on its own after reset pulse. The controller doesn't drive busy until it receives a refresh awake command. Since you confirmed the screen wiring, well, maybe I still need to confirm the screen wiring. What does it say here? The ADC is reading below 2.5 volts. To diagnose, I need the raw millivolt reading on GPO1. Let me add that to the heartbeat. Okay, cool. So it's adding some additional information to the heartbeat just to kind of, okay, and so it says reflash now. All right, so let's do that. Let's go ahead and upload and monitor, and it should rebuild everything. Oh, that's the other thing too, is the battery isn't connected. So that's part of the reason that it's probably getting that battery issue. Okay, so here's what this is saying now. So currently the battery isn't connected because I was worried about connecting the battery while it was connected to my computer and having the ESP32 getting two voltage sources. So I'm going to ask it if I should connect the battery. Also, so the screen is still showing that default message, so it still doesn't display anything but the message it had when I got it. But I see this in the logs. So let's paste in some logs here so it knows what we're seeing. Now let's see what it recommends from here. Maybe it'll tell me go ahead and connect the battery. Maybe the battery, I don't really know a ton about this circuit and how it was wired. Perhaps the battery is needed for this circuit to work. I don't know if it knows enough about this circuit to actually be able to answer that question too, but let me just tell it the battery power is wired to the ESP32 5-volt pin. We'll steer it a little bit. Oh, it says battery is safe to connect. Let's just, yeah, okay. All right, let me unplug the ESP32. Let me plug the battery in. Okay, ESP32 has power. The e-ink screen is still showing the factory default message. And we've got everything plugged in and wired up now. What is it saying? It says, yes, it's safe to connect. The divider is wired. The battery is positive. Terminal goes high. Blah, blah, blah. Okay. The screen is like, this is what worries me. Logs say partial refresh is being issued, returning by the screen. Wrong panel model. Let me see what panel model. That, I mean, that's a good thing to check, right? Does this say it's I mean, I don't really. It's a WeX Studio. It doesn't. Does it say anything on here about what model it is? I'm just gonna type in everything I see and see if we can figure it out. The screen is a 2.9E paper module designed by WeX Studio with 296 by 128 resolution. I don't see any other information on it that would tell me what it is. I'm also not 100% sure the wiring is correct. We just provided that information. Let's see what it says, because I'm not 100% sure the wiring is correct. I also want to upload monitor the new, because I'm curious now if it tells me the battery's connected, if it realizes that now in the serial monitor. Okay, it says, oh, look at that. That model uses an SSD 168 family controller, not the. Oh, excellent. Okay, so it is incorrect information right now. Okay, so it updated that, so let's reflash. Maybe that has been our problem the whole time. And so I'm going to go ahead and make sure and drop you over to the other camera and zoom in a little bit, so that if this goes and it works, which I'm hoping it will. Oh, look at that. Look at that. Okay, now it's kind of flashing like crazy. That's not what I was hoping for. But, hey, I mean, this is something, right? Okay, let's say currently the screen did wipe the default message, but now it's just red. Nothing else. Also, oh wait. Oh, no way. No way. Do you see this? Ah, you see this? How cool is that? How cool is that? Oh, yeah, the battery still doesn't display anything. So I need to see if I can fix that. Also, I would prefer it to be black and not red. I want to try and get this where you can see it. Okay. So currently the battery is connected, but we get bat NA in the logs. Also, the E paper screen is working now, but it's got a red tint to the background and all the text is in red. Could we make the text in black with a white background and the title be YouTube subscriber counter with but show a YouTube logo. See if it'll let me do that, or if it's going to be telling me that YouTube information is copyright and it's not going to let me do that. It's possible it'll say that. We'll see. We will see. Still, it's super cool that it's actually like working. Yeah, it's super exciting stuff. So, just kind of figuring some stuff out right now. Okay, so it looks like it switched to a different driver that was a 3-color driver. That's cool. And it's going to redesign the layout with the YouTube play button logo drawn from primitives and the new title. That's cool. Okay, so for some reason it's doing a full refresh, but we haven't flashed it with anything new. So now it's going to get the raw reading. Okay, so it's done. Oh, on the battery side, what does it say? 2 issues. Oh. Because the battery, let me just make sure the battery goes here and this, sorry, I do have a TP4056 in line. Just so it knows, so it doesn't worry about that. But let's go ahead and do a flash where we can build, upload, and monitor this and see what happens. Oh, wow, look at that. That is so cool, isn't it? Can you see it? Oh, let me see. Bring it closer so you can see it better. Oh. Okay. I got a couple of minutes left and then I got a jet, but I'm just going to see if real quick can I plug in some Wi-Fi information. And so I can't let you guys see my computer right now because that would be like totally bad because you'd be like getting all that information and everything. But not trying to be rude or anything. Where does this go? I'm trying to get an API key real quick. Sorry, I try not to take forever, and then I'm like not talking at all, and it's like, what is he doing? But sorry about that. Give me just a second. Just need. Okay, where does this go? One of the things is I got to figure out why it's doing that pulsing, and see if I can solve that in the future. I don't know if that's what the problem is there exactly. Also, it's interesting, I noticed too, and I don't know if you can see this or not, but I thought everything should be wired up so that the battery voltage would work. But the battery voltage, I believe, should be like right in this area right here. And I don't know if you can see that or not, but there's no battery voltage. So it's not showing anything there. So that's something that I got to figure out and try and fix as well. But let me just see if I can get the sub counter working real quick. before I have to jet. Okay. This should theoretically be it. It's building now. We'll see. We'll see. We'll see if it gets connected to the Wi-Fi. I don't know if it even tells you if it gets connected to the Wi-Fi or not. I don't think that's anything that's on the display. But that's it. I flash everything to it now. And nope, that didn't work. All right. Well, that was fun, but I gotta run. Hopefully, I can get this project finished, and when I do, I'll update you on how everything went. Anyway, till next time.